Hi guys, it's me Subhendu and welcome to my video on video compression. In this topic we will discuss about the video compression, how many parts of video compression and also the algorithms of video compressions, and after that I will show a demo of my project which I have done. So firstly, starting with video compression. What is video compression? Video takes up a lot of space, as we all know. Uncompressed footage from a camcorder takes up about 17 MB per second of video. Because it takes up so much space, video must be compressed before it put on the web. Compressed must means that the information is packed into a smaller space. There are two kinds of compression, lossy and lossless. Lossless compression means that the compressed files has less data in it than the original file. In some cases, this translates to lower quality files because information has been lost, hence the name. However, you can lose a relatively large amount of data before you start to notice a difference. So, in brief, lossy compression makes up for the loss in quality for producing comparatively small files. For example, as we DVDs, you generally use MPEG-2 format. Next, come to the lossless compression. In the lossless compression is exactly what it sounds like. Compression where none of the information is lost. This is not necessarily as useful because files often being the same size as they are before compression. Here I have given a short description of video compression, and I also tell you about how the video compression works and what are its parts. Next, I will straightly come to the various algorithms which generally helps in video compression. Some of the video compression algorithms are run length encoding algorithm, arithmetic coding algorithm, Lempel-Wealth LZW algorithm, BWT algorithm, PPM algorithm, CM algorithm, Hoffman coding, adaptive Hoffman coding, DCT algorithm, and Shannon-Fano coding algorithm. But in my paper, I will only discuss about the run length coding algorithm and arithmetic coding algorithm. But before going to describe the algorithm, first I will explain what is a video. As we all know, a video is generally a set of images. Here I generally divide the various images into a frame in a video, and as a result, all the data from the frame is extracted as an image, and that image is generally compressed, and after that it is again collaged to form a video. So firstly I will explain the steps of compression, how it is done. Generally a frame is generally converted into 8x8 blocks, and then we apply DCT algorithm on that. After that, quantization will occur, and after we will use the compression algorithm, that is RLE, AC, or any other type algorithm. Now I will tell you about some of the frames. There are generally three types of frames: I frame, P frame, and B frame. What is I frame? It is generally intra-predicted. P frames predicted from last I or P reference frame. B frames bidirectional, predicted from two reference, one in the past, one in the future. Thus out of the order decoding is needed. Next I will straightly come into the run length coding algorithm. So in the encoding part, first we take 2 bytes. Then if the 2 bytes are equal, we will output both of them, or count how many bits they are repeated, then output that value. Then I will update the pointer to the input file, then get the next 2 bytes and repeat the same process. So, and again, if no, then we output the first byte, put the second as first, get a byte for the second, and update pointer to the input file to repeat the process. Next we will straightly go to the decoding part of run length encoding algorithm. Firstly, in run length encoding algorithm decoding, we first take 1 byte. Is it the current byte equal then to last? If yes, then we will take another byte. This is a counter. We will put current byte in the output file, copy the counter times in the last byte, and put the last copied byte in the last and repeat the process. If no, then we will bind the current byte to the output file, now last in the current byte, and repeat again. The some of the tutorials of the arithmetic coding algorithm and the run-line coding algorithm is given in my GUI. So you can access them and can easily understand what is run-line coding algorithm and arithmetic coding algorithm, which is described in my paper. But after looking at the compression factor, I have made some modifications in the run-line coding algorithm, and as a result it will show the main values of the compression factor of my algorithm. So we have already described all this, so I will straightly go to the demo of my work, the implementation of the modified RLE algorithm, which I have done by modifying the RLE algorithm which I have just described. Next, I will straightly go to my GUI. Here in the GUI, it is a simple GUI, but it will show all the results which you want to see. So next, here you can see give input and show all the resultant time in serial as well as in parallel. So I will straightly now go to the results. So in the results, I have done implemented it in MATLAB. So I am running this file, and it will take a few minutes or a few seconds rather. Then I will give input as all files I will take. Then I will give input a video which has an AVI extension, and then I will run it in serial first. Then we have to wait until the whole process is finished, and let's see how much time the process will take in the serial part. Next, after that, I will run it in parallel and show what's the difference between the serial and the parallel part. So it is running, and I think what's the output it will give, I can't imagine, but it has given the elapsed time as 32 seconds. Next, I again run the same input in parallel. And same input I am giving, and I will run it in opening this file, and I will run it in parallel. So I will again have to wait. In parallel it will take much less time, but it is taking just a little bit extra time because of the overhead factor. As we all aware about the overhead factor, that it will for assigning the jobs to all the 4 processors, it is generally taking time. You can see that it is assigning all the values to the other processors here, waiting for parallel job to start, and it is getting the local all the C's, and it is connected to MATLAB session with 4 layers, and MATLAB pool session 4 layers, and after that it will show the output here. So please wait for some time, and now here we get the output as 17 seconds. So you can generally see that it is almost half the time what is required in serial. So and another thing what I have to show, that the video which is formed after compression, whether it is compressed or not. So I am saving this in desktop. Suppose name imply.cfg. It already exists, so I replace that file, and let's see whether it is compressed or not. In the original file, the file size, the file size is generally 176 KB. Now go to the compressed file. Sorry. Now in the compressed file, compressed file, that's the implied or CFG. Here it is compressed to 1.02 kb. So if we show the compression factor, it will be around point something 066 as I have calculated. So let's see what's the compression factor. Here, as I told, it is 0.0057. So after modifying the RLE algorithm, I get better compression factor as that. As in my paper, it is given that after compressing any FLV file, just wait, I will see you. After compressing any FLV file, AVI file, sorry, it will give a compression factor of about 155. But it is again. But my algorithm will give a compression factor of 0.0057. So I think the proposed algorithm of mine is better than that. So that's how I have implemented my assignment 1, and that's from my presentation or the video presentation on video. So thank you, and thanks.